All right, Kim Shepard one more time with video 9L, the last in lesson 9. So let's wrap up regression. So one last comprehensive example. The data that we're going to use. We had statistics students visit the library a few semesters ago. Each student was to select a book and then record several variables with that book. And so we have an excerpt of the data set here. You can see they have the title of the book, the year, the weight, the pages, the thickness. The variables that we're interested in for this problem are the number of pages. That's going to be our X explanatory variable. We're going to use the number of pages to help predict the weight of the book in kilograms. So weight will be our Y variable. We had 115 students that participated in this. And again, this is just a small clip of some of the StatCrunch data for this one. All right, so the first thing you should do when you want to look at two quantitative variables and see if there's a relationship between them is to produce a scatter plot. So you have a scatter plot in your notes. Again, we're using the number of pages to help predict the weight. You can see the scatter plot here as well as the linear regression line is included. We do see a positive linear relationship. It's probably not an extremely strong relationship, but it does look like the more pages that the book has, the more it tends to weigh. Okay, some other pieces of output that you have. You also have the residual plot. Remember, that's still our X variable down on the X-axis, but now we're plotting this versus the value of the residuals. And so a residual equal to 0 would be here. We have many positive residuals, some negative residuals. So we'll be looking at this in a minute as well. And then at the bottom, you've got just some StatCrunch output. We've got the linear regression model, our sample size, the correlation coefficient, R squared, as well as the error standard deviation. So keep page 125 close by, and we're going to keep flipping back to this as we answer a series of questions. So if you turn the page, question A. Based on the scatter plot, describe the relationship between pages and weight of a book. Be sure to incorporate the correlation coefficient in your write-up. So if we go back to that, some of the things we'd want to say, the relationship looks positive. It looks fairly linear. It looks okay as far as strength goes. It doesn't look extremely strong. With strength, you can also incorporate this correlation coefficient. This tells us it's more of like a moderate in strength. And then the only other thing you might comment on, is there anything unusual? It does look like that for larger books, there were a few points that were pretty far off the regression line. They're probably going to have larger residual values. There was a smaller book here that might have a decent sized residual value as well. So let's write that up. So the relationship looked fairly linear. It was positive. I would say moderate in strength, and we can back that up with the correlation coefficient. Or was 0.729. And there perhaps were a few outliers, especially for those larger books. Far from our line. Those books that are far from the line will end up having large residual values. So fairly linear, positive, moderate in strength, and maybe a few books that were a bit away from our line. So that's the scatter plot. Okay, question B. And on these there's a lot of writing, so at any time pause the video if you need to catch up and copy everything down. You should copy everything in your notes. Let's check the conditions using the scatter plot and the residual plot for the appropriateness of running a linear regression analysis. So remember, there's three things that we're looking for. We want to make sure that we have a linear, the relationship looks linear. We want equal spread in those points. And we also want to see if we happen to have any unusually large residuals or outlying points. So let me go back and then we'll write this down. The relationship looks pretty linear. If you look at that scatter plot, we can back that up. Here's the line, the residual equal to 0. As long as it looks linear, there shouldn't be any pattern left over here. And we don't see a clear pattern to these points. It does look like a nice random scattering. So that backs up the fact that the linear model is a good choice. As far as equal spread, we want these points to be equally spread from our regression line as we move to larger x values. It does look like, they're spread out here. Perhaps for the larger books, there's a bit more spread. This also gets to be a little bit difficult because there aren't as many books that were large. And we sort of see the same thing with the residual plot. Here's the spread of the values, although really we kind of draw a line how spread out they are. There's some spread here, maybe just a smidge more spread out for the larger books, but not a whole lot. Some of this gets to be a little bit subjective. So some of you might say equal spread, some of you might say, I think that was violated a little bit. The big thing with statistics, make sure that you back up what you say. So if you think that equal spread is violated, explain that. This one's a little, could kind of go either way. The third thing, if we look at points that have very large residuals, there are some of those. This point has a fairly large residual. This point's got a fairly large residual. And then have to decide which ones you want to include here as large. But clearly these are the two that are the largest. We might want to go back into the StatCrunch data set and just look up those two books. Make sure that there weren't any typos or any other issues with those, that they were bound in a different way or that they were in some way different from the rest of the books. All right, so let's summarize the three things we just said. First thing with regard to being linear, the scatter plot's linear, the residual plot doesn't have a pattern, so it looks like linear is a good choice. These two together tell us a linear model is a good choice. It says choice. Equal spread. I'll let you justify what you're going to say with this one. You could say, yeah, they look like they were roughly equally spread, or, oh, I'm not so sure. Once you got out to those bigger books, I think that the spread got more spread out there. It didn't get that much more spread out. But again, a lot of this is kind of subjective, so I'll let you fill in your notes what you want to say about this one. We'll be looking at lots more of these in class if you have a question on that. So make sure you write something there. Number 3, we're looking for unusual points or points with large residuals. There might have been a couple there that we'd like to investigate. A couple of those books had large residuals. So for those, we might want to go double check the data. Make sure there wasn't some kind of typo in entering that book or that that book was in some way different from the other books. They weren't extremely different from the rest of them, but something you might want to go back and look at. So overall, there weren't like glaring violations here for the appropriateness of a linear model, but a couple things that we might want to look at a little closer. All right, part C. Interpret with the sentence in context the value of the slope. All right, let me go back. The slope. So here's our regression equation. Remember, the slope is the coefficient that's being multiplied by x. It's connected with x. So this is our slope. And we want to write a sentence to interpret that. As the book increases in pages, and so this, for the slope, for each additional page, one page that the book has, the model predicts that the weight of that book will go up, weight was in kilograms, by 0.00165 kilograms. So for each additional page in the book, the model predicts the weight of the textbook will go up by 0.00165 kilograms. So for each additional page, we can expect the weight to increase because it was a positive slope. That slope value, 0.00165 kilograms. Remember, slopes rise over run. You can think of that slope as that number over 1. And so slope is change in y over change in x. As the number of pages x changes by 1, the weight of that book's going to go up by 0.00165 kilograms. When you interpret the slope, please interpret it in context. Don't just give the number. Don't say as x goes up by 1, this is how y changes. Give it in terms of the variables that are used in the problem. All right. How about the y-intercept? Let's interpret that. So back to our equation. Here is our y-intercept. The y-intercept, you have to think, can I interpret that? And so if x is 0, does it make sense to have an x value of 0? When x is 0, how many pages does that book have? We've got a book with no pages, right? Can't have a book with no pages. And so it doesn't make any sense to interpret the y-intercept. So for this one, the y-intercept is simply a point on the line. That regression line will go through the point 0, 0.126. But it's meaningless to interpret that. So x equal to 0 means no pages. Can't have a book with no pages. So we won't interpret this. The only thing that we'll say here is that the point 0, the y-intercept, that's x, that's y, is a point on our regression line. It's the place where our line's going to cross the y-axis. We might have some small books, but we don't have any books with 0 pages. All right, part E. So sometimes you can interpret the y-intercept, sometimes you can't. If it made sense to have an x value of 0, go ahead and interpret it. This one doesn't make sense. All right, E. For what x values are you comfortable using the linear equation for prediction? I've got to go back and look at our scatter plot. All right, so for what x values are you comfortable using your linear equation for prediction? You only want to do predictions based on the values that you have in your data. So if we look here, this is a bit hard to read here with this scale, but it looks like, this is 100 pages. It looks like somewhere around maybe just under 100 pages. That could be 50 pages. But it looks like the smallest book, if you had access to the data set, you could go back and figure out, hey, what was the smallest book? But it looks like, we've got textbooks that have 50, 60 pages, all the way up to, if I can go out by 100, maybe 1,700 pages. So I'm going to, again, this is just sort of estimating. If this is 50, or this is 100, I'm going to say this is 50. If you come up with, 60 to 1,750, that's fine. But roughly within that range is where we want to make predictions. We would not want to use this linear regression equation to predict the weight of a book that had 5,000 pages. That's clearly off the graph. So for what x values are you comfortable using the linear equation? I'm going to say from roughly 50 pages to 1,700 pages. And again, if you have slightly different answers, that's okay. But roughly in that range, if we had access to the data, we could actually figure out what those values are.
I have a question.
Yep.
Would you feel comfortable predicting way out by 1,700, 1,500, or?
Oh, that's a good point, too.
Just thought of it.
Good question. I like this stuff on the fly. Put me on the spot. Yeah, check out what happens out here with these bigger books. Look at that. Are those larger books, how are they compared to your regression line?
There's not a lot of data out there either, right?
Not a lot of data out there. And, those residual values are getting to be pretty big here, so not as great as predicting for larger x values. That's where that equal spread might come into play and be a little bit of a violation.
I'm almost seeing a line at like 700, 800 where I'd feel really good about it.
Yep.
And then after that, it's almost like the crapshoot out there.
So, what do you do about this? I don't know what you do. You might go, hey, we need some more big books. Or we're going to limit this data set to textbook or to books that are within this size. But it does, you're right, clearly look that after about there, there aren't many. There's 7 points out there, and they are getting to be a lot more spread out from that line. So if you had a textbook with 1,200 pages and you went to predict, we can see where it's going to predict, but you can also see that the points really vary from the line for those larger books. Yep.
Thanks.
Yep. Good talking point. All right, what else do we got? All right, luckily this one was back closer to where we were more comfortable. Otherwise, we'd have to change this. What would our equation predict for the weight of a book that had 755 pages? That was like right around, I think, where we drew the line where we were feeling comfortable. So if you go back and you look at your regression equation, you've got that on page 125. It said the regression equation predicts the weight to be 0.126 plus 0.00165 times pages. And so for pages, we're going to fill in here 755 pages. And we would predict the weight of this book to be 1.37175 kilograms. All right, two more. Interpret with the sentence in context the value of r squared. So you should be getting to be pretty good at this. R squared was 53.2%. Those books, if we looked at all those books, they all weighed different amounts. So if we looked at all those weights, they vary. Roughly half, 53.2% of the variation in those weights could be explained by knowing the number of pages. So 53.2% of the variation in weight, the variable weight, can be explained by knowing the number of pages. It's not fantastic, it's not awful. This also means that the other 46.8% is explained by something else. I just said that number wrong, but I think I did. If you take 100 minus that, we get 46.8. I'm not sure what I said at this point, but is explained by other factors. Alright, so that's R squared. Last item, letter H. Let's interpret with a sentence the value of S sub E, the standard deviation of those residuals, or the standard deviation of the errors. Okay, last part, letter H, interpret with a sentence in context the value of S sub E. S is the standard deviation, that sub E lets us know that that's of the residuals, the errors. So first let's find the value and then we'll interpret it. As part of your StatCrunch output, that is given, the estimate of the error standard deviation is 0.355, so this is S sub E. So now let's interpret that. Let me go back to our scatter plot and talk about it, and then we'll write it down. This is the standard deviation of the errors, right? The residuals. The residuals are how far off you are removed from the line, how far your observed values are from the predicted values based on your linear regression equation. So this is the average spread of those points from the line, the average distance roughly of the errors. So on average, how far off are our estimates from the actual values here? All right. So now let's write that up. So S sub E, the value was 0.355. And so our predicted weights on average are off from the actual weights by about 0.355 kilograms. Your predicted weights are the weights on the line. So our predicted weights are on average approximately 0.355 kilograms off of the actual weights. The actual weights were your actual dots. We'd like that to be small, right? The smaller that is, the closer those points are to your line. All right, so that was a whole example on regression.